Hey all, today we're going to go over data transformation inside STATA software. This is going to be important into getting data into exactly the position you want by using various transformation codings within STATA to generate new variables, to recode variables, and to generally get variables into a position in which we can easily analyze them. So I'm going to go over the examples in the book. To some degree, I've changed some of the codes and I've skipped some things based upon whether I think they're important or not, or just to expedite. But in general, you'll learn everything you need to know to execute the homework in Chapter 3. So first, we're going to start off in the states database. And we're actually going to start with a variable, or generally a question that is near and dear to my heart, which involves judicial selection in the states. So I look at this variable, and first off, I want to tell you something. It's wrong, and it's wrong in a way that everyone who doesn't study state courts makes mistakes. If you look at the partisan selection variable, in which it lists 7 states use partisan elections to select their judges, that's partially true and also very incorrect. But if you want to know more about that, take my other courses on judicial behavior. So what we want to do is we want to generate a variable here that is dichotomous in nature, that takes into account that 2 states elect their judges and the remainder of states appoint their judges in some fashion. So election versus appointment. There are 2 ways to do that, and I'm going to walk you through both ways. So the first way is simply to generate a missing variable. We'll call it judges elected, and we'll make it equal to missing. That's what the period means in STATA. When you tell STATA something as period, that means missing. So what it actually has is it's generated 50 missing values that we're now going to replace with actual real values based upon the previous variable. So we're going to recode judges elected. Missing is going to be equal to 1 if judge selection equals 4. So I did it this way. The book walks you through a different way, but I did this way to show you one thing. Doing commands step by step when you're unfamiliar with STATA is good because you're able to check your work. If you look on the screen, you'll see that judges elected, there were 15 changes made. And that should make sense because we told it to make that variable 1 if judge selection is equal to 4. If you look up to the cross tab that's on the screen, nonpartisan elections is 15. So you would only expect 15 states to be changed. Now we're going to do the same thing, but for partisan judges. And a little STATA tool for you. If your cursor is in the command and you hit page up, it'll bring up the most previous command that you typed. And so since we did it in this iterated fashion, we only need to change one thing, which is judge selection is equal to 5. And you can see we've made 7 changes, which partisan election, that makes sense. Now, because we know we've made exactly this 15 plus 7, these 22 changes in the data, we know that all the other remaining qualities of judge elected should be 0. Because there are 50 states, we know based on the tab above that we're good. So now all missing variables become equal to 0. So judges elected missing equals 0. And if we simply tab our new variable, we should have 22 cases that are equal to 1, and we should have 28 changes that are equal to 0, which is exactly what we have. So we've generated this variable that actually measures whether the judges of the states are elected or appointed. There's another way to do this that's a little faster that you should use if you're more comfortable with STATA lingo. So first we're going to drop the variable that we just created. Dropping it simply means we're deleting it from the data set. And so this is the command that you would use. Since you've already walked through the iterated steps, you know exactly what you want to do. It's called the recode command. So we're going to recode judge selection, parentheses 1 through 5 equals 0. And you'll see why I'm doing this added stuff later. And then we've got 4 and 5 is equal to 1. All right, so we've made 50 changes. Let's make sure it's exactly the same as the one we just had on the screen. It's exactly the same minus one difference. We've changed what are known as the value labels. We probably should work about changing what is known as the variable label. We're going to do that in just a second. In fact, I'm going to do that now because I think it's really important that you learn how to do that right off the bat. And so the way you would do that is label, variable, variable, judges elected. No, we'll read it again. There. Now let's take a look at that tabulate command again. And does state elect appellate judges? No, yes. So there we are. We've made a neat variable within STATA that does exactly what we want it to do. It measures states that elect their judges versus states that don't elect their judges. Now, anytime you get a completed variable that you want within STATA, you should do this. Yes, save your data set. Because oftentimes I've created new variables, ran a model, taken the log, done everything I need to do, and forgotten to save my data set, and I have to go back and do all that work over again. You absolutely don't want to do that. So yeah, save your data set. We're going to do one last step in here. And let's take a look at this variable again. You notice how 21 states use a commission to appoint their judges. I'm getting really bent. The commission doesn't appoint judges. In most cases, in all states except one, Hawaii, a commission makes a recommendation to the governor, and the governor then appoints. So saying appointed by commission, not accurate in any state except Hawaii. But we'll just go that means that there is a merit selection committee that select judges. And there are 21 states that do that. Let's say we want to make a dichotomous variable in which that's 21 and 1, 21 and 0. Now, the nice thing is because all of those variables are in one category, we can actually use a much easier command to do this. We're just going to tab this variable. Literally, we're going to do this again, except we're going to add an extended command on it. We're going to generate Now what this will do is it will create a series of dichotomous variables, 1 and 0, that are for appointed by commission, appointed by governor, appointed by legislature, nonpartisan election versus partisan, and nonpartisan election. So there will be a series of dichotomous variables, 5 of them, that will be generated. The one we're going to care about is the first one. So let's just take a look at the first one. See, the output is exactly the same. It doesn't actually do anything on the status screen, but let's take a look at judge selection method 1. You see how it created all 5 of these variables? We're really interested in the first one because that's the one that will be appointed by commission. And you can see appointed by commission 0, 1. So 1, 0, did it exactly what we wanted to do. So that's actually really nice. So what we want to do is we don't care about all those other variables we included. So you're going to drop, and you can type this command out, but I find it easier just to do this. So you see how this is method 1. We're going to drop this one, this one, this one, 1, 2, 3, 4, and 5. We're just going to drop them all. This means delete them from the data set. And now that we've created this new variable, we're going to save it. And so we have this new variable in the data set. We've dropped all the variables we don't need, and we're good to go. The last thing we really want to change is the value labels within the variable. And so remember, we'll page up, take a look at it. It's appointed by commission, so we know what it is, but we don't know 0 or 1. We know that's no and yes. Now, how do you change that 0 to a no and that 1 to a yes? And really all we're doing is we're changing how STATA displays it. STATA will still think it's 0, 1, 1, but STATA will display no and yes. The way by which we do that is we generate a label. So we're going to say label define, and then we're going to make a label that will then apply to a variable. We're just going to call it judge code. And this judge code is 0, no, 1, let's do it again. All right. Since I've already made that variable, we're going to call it judge code 1. So you see we've created this label, judge code 1, that simply has no or yes. Now we're going to apply this label to the variable. So label values judge select method 1 gets judge code 1. STATA doesn't look like it did anything, but let's take a look. And we'll now have assigned that label to the variable. So now we have another completed and done variable within STATA. So again, we're going to want to make sure that we save it. And you'll have this data stored within STATA. So this is some basics of transforming variables. Next, we're going to work on collapsing variables. Now, your book walks you through a number of commands that I'm not too big a fan of because largely they mess with stuff in the wrong way. So I'm going to show you the one right way that STATA does, or that the book does for you. And we're going to open up the NES for that. So we're going to take a look at this variable police, which has some problems. Yeah. All right, hold on. All right, back. I made some changes to the data, and I did exactly what I told you not to, which is forgot to save. So I had to go through and adjust some of my changes back to where they were so that we could actually do this. So take this variable, this continuous variable, and break it down into a smaller size. So we're going to collapse this interval level variable into an ordered variable. Most of the time when you're working with data, you don't want to simplify the data for analysis, but it might be really important to simplify it in terms of display. So when you actually are presenting the data, it'll be easier to actually understand. So we're going to break this down into what we call quantiles. The command for that is xtile. And so we're going to xtile this command, ftile police underscore. We're going to make the first one 3. And that this Q3 at the end, by the way, is just it's just what we're going to call the variable, and it is going to be equal to make sure to add the analytic rate. In the NES, it's NESW. And we're going to, how many n quantiles do we want? 3. So we're going to take this variable, which as you can see on the screen ranges from 0 to 100 with a mean of 74, so approval rating of the police is fairly high, and we're going to break that data down into 3 equally spaced quintiles. So it's going to break it down to 3 data points, which will basically come to low, medium, and high. Did I spell quantiles wrong? I probably did. Or I missed a comma. There we are. So now we've made this variable with 3 quantiles. Now we're just going to take a look at it. And you can see we've broken it down to 3 quantiles. Now, the book also does 4. Turns out that's really easy. You just hit page up, hit the command, and then change the variable name to 4, and hit enter, and there you go. And do the same here. And you've got, instead of broken down into 3 quintiles, you have it broken down, or 3 quantiles, you have it broken down into 4 quantiles. And this is just a simply neat and easy, dirty way for the data set to be divided evenly. You can see that there are some problems with it for obvious reasons, like this third category in this data really only has 5% of the data, so one would argue it's probably not necessary, but it's just STATA doing a quick and dirty way of breaking the data down into some neat, neat sets. So lastly, what we're going to do is we're going to work on, well, not lastly, we're going to work on a standardization. Actually, I'm going to make that a new video. Thanks all. I'm going to make 2 videos this week. The next one is a little more in depth, so I'm going to stop right here. Thanks all.